In this class, now I explain you some applications related to circles chapter. Those applications are related to equation of locus of a point. These locus based applications are very useful in competitive exams. Now let us learn those locus based applications from circles chapter. Now let us see the first question. Find the equation of locus of point of intersection of perpendicular tangents drawn to a circle x square plus y square equal to r square. See, one circle equation is given, that is x square plus y square which is equal to r square. You know, on the circumference of the circle there are infinitely many points. You know, at every point you people can able to draw a tangent. Okay, right. See, now I am drawing some tangents. See, like this you can draw infinitely many tangents. So these tangents, suppose observe this pair of tangents which are intersecting at this point. Observe this pair of tangents which are intersecting at this point. Observe this pair of tangents which are intersected at this point. Observe this pair of tangents which are intersected at this point. Like these tangents will intersect outside of the circle at infinitely many points. But here we require to find locus of a point where the angle between the tangents is 90 degrees. Observe carefully. What we would have to find in this problem? We have to find the equation of a point. Equation of locus of a point where the angle between the tangents is 90 degrees. So here we may get this kind of points outside. Now connect all of them. So you people will get a circle. So that is our required locus. On this locus, angle between the tangents drawn to this circle is 90 degrees. Now let us find whose equation. So find this equation. Consider this point P as x1 comma y1. Now from this point to already we have drawn two tangents. You know, this is center of the circle and this is radius of the circle. You know this formula, tan theta by 2 which is equal to r by root s11. Generally we use this formula to find the angle between the pair of tangents drawn from exterior point to the circle. Okay, so to find this required locus equation, I have taken this tan theta by 2 equal to r by root s11. See here students, you know here angle between the tangents is 90 degrees. Put theta is equal to 90. If you write here theta is equal to 90, then it will become tan of 90 by 2 equal to r by root s11. 90 by 2 which becomes 45. As you know, tan 45 is equal to 1. Now bring it to the left side so that here you will get square root of s11 which is equal to r. You know this notation s11. Equation of the circle is given, point is there with you. So what is s here? Transfer this r square to the left side so that here you will get x square plus y square minus r square, and with respect to this point s11 is x1 square plus y1 square minus r square. Right? So here, before going to substitute S11 over here, take square on both sides. If you take square on both sides, S11 is equal to R square you will get. So here, write this S11 over here, then it will become x1 square plus y1 square minus r square, which is equal to r square. You know, this point P, here I have taken whose coordinates as x1, y1, but this point P can be taken anywhere on the circumference of dotted circle. This is our required locus, no? So that here, this in the final answer you must replace x1, y1 by xy. Why do we replace this x1, y1 by xy? You know, because this point P is not fixed here. It can be taken anywhere on the dotted circle. So that point should be a variable point, or you can call it as locus point. Hence, we have to replace x1, y1 by xy at the end of the solution. Okay, replace this x1, y1 by xy and transfer this one to the right side, so that you will get 2r square. Okay, so this is our required equation of locus. So in the mathematics, there is one special name to this locus, that is called director circle. What do we say this one? Director circle. How do we define a director circle? Director circle is nothing but a locus. On this locus, angle between the tangents which are drawn to this x square plus y square equal to r square is 90 degrees. The locus of point of intersection of perpendicular tangents drawn to this circle represents a circle whose name is director circle, whose equation is x square plus y square equal to 2r square, where r is the radius of the given circle. I hope you have understood this. Now from this diagram, we people can able to write one more equation of locus. See that. See, next let us see one more question from this diagram. Find the equation of locus of a point where the angle between the tangents drawn to this circle is theta. In the previous one, we have taken this angle as 90 degrees, but now I am asking you to write a locus on which angle between the tangents drawn to this circle is theta. How these tangents are inclined, which are inclined at an angle theta. So find this locus equation. Have you understood this question? Find the equation of locus of a point where the angle between the tangents drawn to this circle is theta. So even this question answer also we get by the previous formula only. See here, you are well known to this formula. Tan theta by 2 is equal to r by root s11. Now take square on both sides. If you take square on both, before that, bring it to the left side. Square root of s11 into tan theta by 2. So which is equal to r. Now square on both sides. So here you will get s11. Here tan square theta by 2, which is equal to r square. You know s11. Okay. Write that s11. x1 square plus y1 square minus r square into tan square theta by 2, which is equal to r square. In the next step, multiply these two with tan square theta by 2, r square with tan square theta by 2. So that you will get x1 square plus y1 square into tan square theta by 2 minus r square into tan square theta by 2, which is equal to r square. Transfer this one to the right side so that you will get x1 square plus y1 square into tan square theta by 2, which is equal to, when you transfer this one to the right side, you will get r square into 1 plus tan square theta by 2. You know, 1 plus tan square theta by 2 can be written as sec square theta by 2. See here, x1 square plus y1 square into tan square theta by 2, which is equal to r square into sec square theta by 2. So in the next step, transfer this tan square theta by 2 to the right side. Transfer this tan square theta by 2 to the right side so that you will get x1 square plus y1 square, which is equivalent to r square into secant square theta by 2 whole by tan square theta by 2. See, now simplify this. On simplifying this, what do we get? So here secant square theta by 2 can be written as 1 by cos square theta by 2 whole by, this can be written as sin square theta by 2 whole by cos square theta by 2. So both will be cancelled. Now this what is left here? 1 by sin square theta by 2. So this can be written as r square into cosec square theta by 2. Now in the final answer, you must replace this x1 y1 by xy, because okay, here we need to find equation of locus of a point, so that it must be replaced by xy, because x1 y1 is a fixed point on the plane, but it is a locus. That locus contains infinitely many points, hence it must be replaced by xy. So now x square plus y square, which is equal to r square into cosec square theta by 2. So this is our required equation of locus of a point where the angle between the tangents is theta. So in the previous one, angle between the tangents was 90 degrees. Now replace this theta by 90. 90 by 2, which becomes 45. Cosec 45, root 2. Root 2 whole square, 2. 2 r square you will get. So in the exam, they may give you this theta as 30 degrees, 45 degrees. However, they may ask you. Simply collect the theta and substitute here and go for simplification, so that you will get that required equation of locus of a point. I hope you have understood this. Now let us go to one more application. See that? Find the equation of midpoint of a chord. Find the equation of midpoint of a chord which makes an angle theta at the center of a circle, x square plus y square equal to r square. See this question. Once again I am repeating. One circle is there whose equation is x square plus y square equal to r square. Now here you would have to find equation of locus of midpoint of a chord which makes an angle theta at the center of the circle. See here, this is AB, is our chord. So here this is the center of a circle. See, observe the center of the circle whose center is 0, 0. Let us represent this center with O. Now this is radius, this is one more radius. This chord is making how much angle at the center? Theta. So like that, how many chords will make theta angle at the center? Means infinitely many, because here AB, it may have some length, and here CD, it may have some length here. These two lengths are equal. Suppose AB. If you take AB as 10 centimeters, it may be 10 centimeters, or this chord CD and EF, like infinitely many chords you can draw. Okay students, are you following me? So what I am doing here, I am drawing equal chords. So A, B, C, D, E, F. Okay, if you want to take like MN, many chords of equal length you can draw in a same circle. Am I right? So, you know, you read one property in the circles. Equal chords makes equal angles at the center. So that, see here, by that property, all these chords will make same angle at the center. Okay, this is O. Now, AB is making certain angle theta at the center. Even CD also will make theta angle at the center. EF also will make theta angle at the center. Even this MN also will make an angle theta at the center. Okay students, equal chords makes equal angles at the center. So, by that property, you can draw many more tangents of equal length in a circle. Now, identify whose midpoints. Identify whose midpoints and connect all these midpoints. Again, you people will get a circle which is concentric with the given circle. Okay, so here you would have to find this circle equation. How the circle is forming? By connecting the midpoints of chords having same length. Having same length. So, right, now I am going to find that required circle equation. How it is formed, I explained you. I think you have understood it. Now let us find whose equation. To find that equation, so see students, take the midpoint of this chord AB. Let us consider whose coordinates as x1 comma y1 and drop an altitude from center to AB. I am dropping, and where it will meet, if you drop an altitude from center to AB, which will meet midpoint of chord, you know that. Now this angle will be how much? Theta by 2. This one also theta by 2, because this is an isosceles triangle. OA, OB both are equal na? So hence this altitude will divide this vertical angle into two equal halves. So this angle is theta by 2, this angle is theta by 2, this is radius R. Now with respect to this theta by 2, in OPA triangle, define cos theta by 2. If you define cos theta by 2, so here adjacent OP by hypotenuse R. Now cos theta by 2, so which is equal to OP length. How much is the OP length? Root of x1 square plus y1 square by R. Now take square on both sides. Transfer this one left side and square on both sides, so that you will get x1 square plus y1 square is equal to R square into cos square theta by 2. In the final answer, replace x1 y1 by xy. X square plus y square is equal to R square into cos square theta by 2. So this is our required locus equation. What is this? Equation of locus of midpoint of a chord of this circle, which makes theta angle at the center of the circle. So in place of this theta in the exam, they may give you any angle. Either it may be 30 degrees, 60 degrees, 75 degrees. So whichever locus you require, so simply collect that angle and substitute here and go for simplification, so that you will get equation of that locus. Now let us move to one more application. See that find the equation of locus of a chord. Find the equation of locus of midpoint of a chord. Find the locus of midpoint of a chord of a circle x square plus y square equal to r square having length 2k units. See here, this is circle whose equation is x square plus y square which is equal to r square. Now here one chord is given whose name is AB and whose length is also given in the problem. AB equal to 2k units. Now find the midpoint of locus of this chord AB. How do you find? Have you understood the question? Find the equation of midpoint of a chord of this circle having length 2k. So, see, observe students, here we have taken a chord AB of length 2k. How many this kind of chords can be drawn into this circle means infinitely many, like previous one. Here it may have 2k length, it may have 2k length, it may have 2k length, 2k length. So, identify whose midpoints and connect all of them. You will get a circle, no? So, that circle is also concentric with the given circle. Now, find that locus equation. How do you find? See here, identify the center. Let us name center as O, whose coordinates are 0, 0 and drop an altitude. So, connect this center with A. This is radius and you know AP length. So, this P will divide AB into two equal halves because P is a midpoint. So, AB is having length 2K now. Hence, AP will be K, PB will be K. Now, here, okay, what do? So, take this right angle triangle OPA and apply the Pythagoras theorem. So, here, which is hypotenuse? OA. OA means here R. R square is equal to AP square. AP square means K square plus OP square. Now, let us simplify this. R square which is equal to K square. OP square is how much? OP length x minus 0 whole square which becomes x1 square, y minus 0 whole square which becomes y square. Here square is there so that your square root will not come. Now transfer this one to the left side so that you will get x1 square plus y1 square which is equal to r square minus k square. Now in the final one, replace x1 y1 by xy. So x square plus y square which is equal to r square minus k square. This is our required locus equation. Now let us go to one more application. See, find the equation of locus of midpoint of a chord which moves k units away from the center of the circle. See here, this is the circle whose equation is x square plus y square is equal to r square. Now, see here, this is a chord. What you have to find? Midpoint locus. How this chord is moving k units away from the center. You know, the center coordinates 0, 0. So, how many chords can move k units away from center means infinitely many, like previous. Like here you can draw one chord, here you can draw one chord, here you can draw one chord. So equal chords maintains equidistance from the center of the circle. You know that. So that infinitely many chords can be drawn to the circle which maintains k units from center of the circle. So here I took a chord AB. I identified midpoint coordinates x1, y1. So here this length is given as k units. Now we would have to find this midpoint locus. How do you find? Very easy. Just take OP equal to k. That's it. Okay, what is the distance from O to P? x1 square plus y1 square which is equal to k. Now take square on both sides. x1 square plus y1 square is equal to k square. Now replace x1 y1 by xy. so that you will get x square plus y square equal to k square. This is our required locus equation. Okay. Now let us go to one more application. See that. Find the equation of locus of a point which satisfies this relation cot theta 1 plus cot theta 2 which is equal to 0, where theta 1 and theta 2 are inclinations made by pair of tangents drawn from a point P x1 comma y1 to a circle x square plus y square which is equal to r square. I hope you have understood this question. Find the equation of locus of a point which satisfies this relation cot theta 1 plus cot theta 2 which is equal to 0, where theta 1 and theta 2 are called inclination made by the pair of tangents drawn from this point to that circle. Now let us see the solution for this question. See students, one circle equation is given whose equation is x square plus y square which is equal to r square. Now here one point P is there whose coordinates are also given in the problem x1 y1. Now draw two tangents to the circle. One is touching at A, one more is at B. You know students, slope form of tangent equation y equal to mx plus or minus r into root of m square plus 1 is the slope form of these two tangents. Both are passing through x1 y1, so that replace this xy by x1 y1, so that here you will get y1 is equal to mx1 plus or minus r into root of m square plus 1. Now transfer this one to the left side, so that you will get y1 mx1 which is equal to plus or minus r into root of m square plus 1. Now let us take square on both sides for this. If you take square on both sides, the left side looks like a minus b. A minus b whole square formula y1 square plus m square x1 square minus 2x1 y1 m, so which is equal to r square m square plus r square. I hope you have understood. Now I want to erase this solution. See here, simplify that. If you simplify this, what do you get? Now transfer this one to the left side and take this m square common from both. If you take m square common from both, x1 square minus r square which is equal to m square, here 2x1 y1 m. Now transfer this one to the left side, so that you will get y1 square minus r square which is equal to 0. Now you know students, x1 y1 is a fixed point on that plane, means it may have some numericals, real numbers as coordinates, x coordinate, y coordinate. But here we do not know the m value, where m is slope of the tangent. So here it is a one quadratic equation in terms of m. Here having m square second degree term, here first degree term. This is there is no m, means constant. So here it is a one quadratic equation in terms of m. On solving this quadratic equation, we will get two values for m now. Let us consider those two values as m1 and m2. Now find whose sum. So here m1 plus m2 which is equal to minus b by a, minus of minus which becomes positive, 2x1 y1 by x1 square minus r square you will get, and if you require to write product of the slopes, you can y1 square minus r square by x1 square minus r square. What are m1, m2? Tangents, slopes of tangents drawn from P to that circle. In the previous diagram I have shown you. Right. See, students, in the problem, what are given? They mentioned theta 1 and theta 2 are called inclination made by the tangents with tangents. Theta 1, theta 2 are called inclinations of the tangents. No? When the inclination are given, how do you find the slope of the tangent? m1 is equal to tan theta 1. You know, when the inclinations are given, to get the slope, you would have to define that inclinations, tangent ratio with respect to that inclination. Now, how do you get m2? Define tangent ratio with respect to that inclination theta 2. So, observe that here m1 is nothing but tan theta 1, m2 is nothing but tan theta 2. But in this current problem, what you would have to find? Locus of a point which satisfies cot theta 1 plus cot theta 2 which is equal to 0. Now express this cot in terms of tan 1 by tan theta 1 plus 1 by tan theta 2 which is equal to 0. Now take cross multiplication. If you take cross multiplication, what do you get? See here, tan theta 1 plus tan theta 2 whole by tan theta 1 into tan theta 2 which is equal to 0. Now transfer this one to the right side so that you will get tan theta 1 plus tan theta 2 which is equal to 0. Here tan theta 1 plus tan theta 2 is nothing but this, no? Now write that value over here. 2x1 y1 by x1 square minus r square which is equal to 0. So transfer this one to the right side so that you will get, so here x1 y1 is equal to 0. In the final answer, you must replace x1 y1 by xy. So xy is equal to 0 is our required locus equation. I hope you have understood these applications. Thank you one and all.